Welcome to the webinar. All right, well, the full open source release of DRAGEN-GTK version 1.0 is officially out, which is why we've put together this GTK release webinar for you, so you can get all the information that you want, where to find DRAGEN-GTK, how to use DRAGEN-GTK, what is DRAGEN-GTK, and why you should care, right? So hi, everybody. My name is Derek. I'm a science writer here at the Broad, and today we're all very fortunate to be joined by a panel of experts here with DRAGEN-GTK. Coming to us from Illumina, we've got Heidi Norton and Deepthi Shankar with us. Heidi is going to be giving us a talk on bringing Dragon to GTK, so let's look forward to that. From the Broad side of things, we've got a small chunk of our GTK experts. Michael Gatzen is going to be giving us a talk on functional equivalence, so let's look forward to that. And of course, making sure that everything works well in the background, we've got our customer delivery team making sure that this webinar goes smoothly. So with that, we are planning for this webinar to be short and concise, about an hour long. So I'm aware of the time. I don't want to waste your time, and I don't want to, I don't know, waste anybody's time like I'm doing right now. So why don't we just get on with it? Here's the agenda for today. We've got background and overview. That's what we're doing right now. And after that, we will have this talk on bringing Dragon to GTK, followed by a brief talk on functional equivalence between Dragon and DRAGEN-GTK, how the results from both of those compare and how we can find that out. Afterwards, we're going to have a walkthrough of our DRAGEN-GTK workspace that we have on Terra. I'll show you how to do that, and also how to take those that pipeline and run it anywhere else that you want as well. And following that, we'll have a developer Q&A. And of course, what is a Q&A without some good cues? So please, if you have any questions, please post them in the chat right now or as they come to you. And we will try and answer as many as we can. Of course, like I said, this is a brief webinar. And if you think of anything after the fact, we do have a forum on the gtk.broadinstitute.org website. Just go to the forum link, look for the DRAGEN-GTK webinar discussion subsection, and there you can post any of your questions after the fact. We will also try to answer as many of those questions as we can. So enough with organizational stuff. I've done enough of these to know that people's eyes start wandering if you don't get to the meat of the topic. So let's just get into it, okay? So what is Dragon? Dragon is a genomic analysis platform that was produced by Illumina. It uses very specialized hardware accelerated processors in order to run genomic analyses quickly and accurately. And it's even good for running things in difficult to map regions. This makes it particularly good and easier to run and analyze large scale sample sets if that's what you have. GTK, on the other hand, I don't think it needs any introduction with this audience, but it's the industry standard for SNP and indel discovery in germline DNA and RNA-seq. It's developed by the Broad, and it provides a number of open source tools that can be used in order to run analyses and pipelines. And of course, recently, a while back, Illumina and the Broad decided to have a partnership, and that's why we came together and brought you DRAGEN-GTK. DRAGEN-GTK, it provides researchers like yourself with tools that are fast, reproducible, and accurate. And also, because of the fact that DRAGEN-GTK best practices contain open source workflows, that means that they are compatible between Illumina's platforms and the mainstream infrastructure that you're probably already using. We've actually already got a lot of resources and information online that explain in more detail the interplay between Dragon and GTK and how this collaboration came to be in the first place. But I'm not going to step on any toes because Heidi Norton will present on that after me in a lot more detail. However, in the meantime, I think that a quick 20-second rundown of the benefits of DRAGEN-GTK can be summarized like this.
Chocolate.
Peanut butter.
Hey!
Oh, hey, you got your chocolate and my peanut butter.
Peanut butter on my chocolate.
What?
Delicious.
Two great tastes that taste great together.
Right, DRAGEN-GTK it harnesses the tools of Dragon with the ease of use and accessibility of GATK in order to create something that's even better together than they are separate. Plus, the fact that DRAGEN-GATK is open source means that it doesn't necessarily need to run on Illumina's proprietary hardware accelerated platform unless you want it to. So that means that you can run DRAGEN-GATK on your laptop or your institute server or whatever it is that you're currently watching this on. So the question is, how does this actually run? We need to make it clear that DRAGEN-GATK and Dragon do not process data exactly the same. Both Dragon and DRAGEN-GATK run off of separate code bases, and both of them are under active development right now. And so as a result, it's basically impossible for the output of both of them to be identical. I know that sounds a little shady on the surface, but we can think about it like this, right? Even given access to exactly the same ingredients, no two chefs are going to be able to produce exactly the same meal, even if they follow the same recipe. There's always going to be slight differences in their outputs. But why is that? Basically, you're going to have to run into differences in the quality of ingredients that they're using, how the ingredients are prepped, the tools and space that are available, and the actual cooking process that they're following. Sequencing data analysis is like a slightly less edible version of that, except instead we're dealing with differences in the ways that samples degrade between different institutions and the way the computers filter data when different resources are allocated to them. So as a result, we're always going to have a certain amount of background noise that's unavoidable between any two methods of variant calling when we're trying to compare them. Dragon, of course, uses this proprietary hardware accelerated version of the variant calling pipeline that we're going to be looking at today. Meanwhile, DRAGEN-GATK uses an open source software implementation of that. So our goal with DRAGEN-GATK is not to make sure that those outputs are identical necessarily, but to make it, for all intents and purposes, statistically indistinguishable from the general background noise that you should expect from running these types of analyses. Michael Gatzen has a short presentation about this very topic. So he'll go into a lot more detail than I can. Now, DRAGEN-GATK, like the rest of GATK, can be installed and run from the terminal. And you can probably run it from your smart fridge probably, but you can also easily run it from the cloud using Terra. Terra is our cloud native platform for accessing data, running genomic analysis tools, and for collaborating and sharing with others once you have all of the aforementioned ready. So today what we'll be doing is walking through our featured workspace in Terra for performing variant discovery on whole genome germline samples. I'll be showing you how to align an array of unmapped reads using the DRAGMAP aligner, and then we'll be calling variants using the GTK tool haplotype caller that will be run in Dragon mode. So we'll do that. If you need to hop off for whatever reason, I'll just let you know that I'll be going through this in more detail in the walkthrough, but for now, you can find that workspace. It's freely available on app.terra.bio. All you have to do is visit the showcase page and then search up Dragon, and it'll be the first item that you see. So speaking of things that are free, we've got a lot of free information for you on gatk.broadinstitute.org. If you go there, we have a link for DRAGEN-GATK right on the homepage. And if you click on there, you will find our launch page for DRAGEN-GATK. It has all of the information that we have for DRAGEN-GATK related to articles, workspaces, videos, and presentations that we already have and that we will have in the future. So probably this webinar might show up there as well. Keep your eyes peeled. And with that, I think that brings us to an end of our introduction. From here, I'm going to be passing the mic over to Heidi, who will be going over more about the background of Dragon and Illumina's collaboration with the Broad Institute. So Heidi, I'll let you take it away.
Great, thanks, Derek. All right, so as Derek mentioned, I'm just going to give a brief overview of the background of Dragon and some of the motivation of working together for DRAGEN-GATK. Can you see my slides? Yes. Great. All right, so Dragon is a commercial software offering from Illumina that provides high-performance secondary analysis. And really, there's three key features that offer benefits to our users. First, it's accurate. It can detect SNPs and indels with industry-leading accuracy. And we can say that because of some recent challenges that we've competed in, like the Precision FDA Truth Challenge V2 for variant calling accuracy, where we won a few key categories on Illumina sequencing data by a pretty comfortable margin. And really, it's both our mapper and our variant callers that contribute to this accuracy. It's also comprehensive. It includes pipelines for analyzing genomes, exomes, methylomes, and transcriptomes with a single platform and a unified command line interface. We also offer integrated targeted callers for more specialized tasks like pharmacogenomics and oncology biomarkers. And it's really fast. That's maybe what we're most well known for. You can fully process a 35x whole human genome in about 35 minutes. And that, fully processing includes mapping and aligning, SNV calling, CNV calling, repeat expansions, as well as targeted callers. And Derek touched on this a bit, but the reason it runs so fast is that many of the core operations and algorithms are hardware accelerated and run on FPGAs, which can execute much more quickly than the same algorithm running on a CPU. Over the last 3 years, since being acquired by Illumina, DRAGEN has worked to continuously improve its speed and accuracy with frequent releases. You can see kind of our timeline of releases along there. And I just want to highlight a few major events along this timeline. So last year, we introduced DRAGEN on board our latest sequencer in 2020, the NextSeq 2000, which enables our customers to get high quality VCF files right off the sequencer as their sequencing run completes for a range of applications. So instead of getting BCL files or FASTQ files that you have to, get off the instrument, figure out what to do with, you can now run DRAGEN directly on the instrument. We've been adopted as the analysis method of choice for the All of Us program. And in 2021, DRAGEN has already been used to process 1 million whole human genomes worldwide. DRAGEN is also a key component of many of our end-to-end workflows, such as TrueSight Oncology and COVID-seq. So with that background about DRAGEN, now let's talk about why DRAGEN-GATK. I don't think I could possibly word it better than Derek's chocolate and peanut butter. That was fabulous. But I just want to go over just a little bit of the motivation here. So there's two main challenges for the genomics community that Illumina and the Broad Institute identified and wanted to work together to solve. And I'm probably preaching to the choir here to talk about these challenges, but the first is that it can still be quite a challenge to get data off the sequencer and turn it into a form that's usable by researchers. And so access to good quality methods is still a challenge. The second is that a lack of standardization of pipelines can create barriers to sharing data. And so as DRAGEN has been gaining traction in global usage, and with GATK as the most widely adopted pipeline, we really wanted to work together to increase interoperability of our two pipelines, while at the same time delivering even better accuracy to the community. So DRAGEN-GATK, that's why we're here. It's a partnership to create gold standard genomic analysis methods, combining the best of DRAGEN and GATK to give you that delicious chocolate peanut butter. So DRAGEN-GATK works to address these challenges by first providing access to highly accurate open source genomic secondary analysis tools to the genomics community. That's why we're here today, to talk about how to use it. Second, it allows for interoperability between open source DRAGEN-GATK and the hardware accelerated DRAGEN. So we'll hear more on this in detail later. But the results from DRAGEN-GATK and a specific version of that hardware accelerated DRAGEN, version 3.4.12, are functionally equivalent, meaning the results are kind of within the noise of sequencing replicates. So Illumina is really excited to have worked together with the Broad to bring these methods to the genomics community. And we'd love to hear your feedback as you start to use these tools. Back to you, Derek.
Thanks, Heidi. Really great summary. And for now, we will then move over to Michael Gatzen, who has a presentation for us on functional equivalence. And I'll let you, Michael, explain what that is.
Yeah, thank you. Well, I will be talking about this concept of functional equivalence that has been mentioned a couple of times now, and how to evaluate that. So usually benchmarking of variant calling pipelines focuses on beating the competition. So if we want to compare two pipelines, we would run both of these pipelines and then take the outputs, compare them against truth, and then look at metrics such as sensitivity and precision, and then determine if one pipeline is better than the other pipeline. However, as studies become larger, datasets are more useful when they're combined. So the idea is to really combine results from different tools or methods or pipelines, which does introduce the risk of batch effects if the pipelines produce slightly different results. So the question is, how can we ensure that data coming from different sources can be used interchangeably and without running the risk of batch effects? And this is the question of functional equivalence. This is exactly what we are achieving between DRAGEN and DRAGEN-GATK. DRAGEN being accelerated on specialized hardware and running on specialized hardware and being closed source, and DRAGEN-GATK, which runs on the general CPU hardware and is open source. How do we evaluate functional equivalence? So basically, as Heidi said, we make sure that the difference due to the tools is smaller than the noise that is just inherent to genomic data analysis. So we take a sample and produce two technical replicates and run both pipelines on each of these replicates. We then compare the difference between the pipelines, one on the same replicate, which is called the inter-tool difference, to the difference or between the replicates, one with the same pipeline, which is what we call the intra-tool difference. And if we find that the inter-tool difference, which is the bias due to the difference in tools, is smaller than the intra-tool difference, which is just the noise inherent to genomic data analysis, then we find that the two pipelines are functionally equivalent. How do we quantify the differences between call sets? So we need to look at two criteria, which is concordance, which is sort of the overlap of calls between two samples, as well as differences in quality, which is what we do when we compare the samples against truth data. For the first criterion, the concordance, we can just arbitrarily define one of the two samples as truth and the other of the samples as the evaluation sample, and then run tools like BCF eval to get a Jaccard score, which measures the concordance between two pipelines or between two call sets. And if we find that the Jaccard score or the concordance between the two pipelines, one on the same replicate, is higher than the concordance between the two replicates, one with the same pipeline, then we find that this criterion is fulfilled. We do this for certain regions and for SNPs and indels separately. And if we find that they all fine, then we say that this criterion is fulfilled. For the difference in quality, we would, as I said, compare each sample against truth and then usually compare metrics like ROC curves. However, ROC curves don't convey all the necessary information, because we could have theoretically the case of two very similar looking ROC curves that, however, if we hard filter at a certain quality threshold, could result in vastly different results. So we use this concept of an F1 plot that tackles this issue and is described further in the technical documentation. So given these two criteria, if we see that both of them are fulfilled in the regions and in the SNPs and indels that we look at, then we define or we say that two pipelines are functionally equivalent. So really, this is a three-way comparison between the outputs of the pipelines, as well as comparing against truth. And this is probably the slide that most of you have been waiting for in this context, which is what configurations of DRAGEN and GATK are functionally equivalent. So we are constantly working to improve compatibility between DRAGEN and GATK. However, at this moment, there are still a few features that are implemented on the GATK side and not yet on the DRAGEN side, and vice versa. So On both sides, we need to turn certain features off and make sure that we use a configuration that actually does produce function equivalent results. So right now, we are equivalent or compatible with Dragon version 3.4.12. And alignment has to be done with a masked version of the HG38 reference. Additionally, we need to turn two features on the Dragon side off, which are PDHMM and column-wise detection. On the GATK side, we are compatible from versions 4.2.2.0 and up. Alignment needs to be done with the DRAGMAP, which is Illumina's open source version of the Dragon aligner, and using the same masked HG38 reference. Additionally, we need to turn spanning band genotyping off. On the GATK side, these configurations are automatically set in the walk pipeline when using this Dragon function equivalence mode argument. And on the Dragon side, you can find the exact command line in the article function equivalence in DRAGEN-GATK. This whole function equivalence evaluation workflow is available on GitHub, as well as a featured workspace on Terra. This is really a generalizable method for comparing configurations, tools, and pipelines, not only specific to DRAGEN-GATK. This is the link. We're also currently working on a publication that is citable in case this function equivalence workflow should be used in other cases as well, comparing different pipelines. Okay, and with that, back to Derek.
Thank you very much, Michael. So now we have a good idea of what DRAGEN-GTK is, how it compares to Dragon hardware, and where we can run it. I thought that we'd take this opportunity to actually show you how you can get your feet wet with DRAGEN-GTK right after this webinar really quickly. So I'll just share my screen. And show you Terra. Terra, as I explained, is our cloud-native platform for running analysis tools and being able to collaborate with other people very easily. And I will show you here the workspace that we already have created for running this DRAGEN-GTK variant calling pipeline. What you want to do is first go to app.terra.bio. Step one, we got to get there. And then make sure that we're logged in. I've already logged in. If you don't have an account, they're free. If we go down here to library, you'll see that we have a showcase button. And if we click here, we can go to our featured workspaces. There's actually a lot of different workspaces that are currently available. The one that we're going to be looking at is this DRAGEN-GTK whole genome germline pipeline. It was recently published, which is why it's at the top of the list. But if you can't find it for whatever reason, you can just do a search for Dragon there, and it's one of the only options. So if we click on that, we will be taken to our DRAGEN-GTK whole genome germline pipeline for variant discovery, and we'll be able to run this. Unfortunately, I'm not able to run this right now because I'm not the owner. So the first thing that we should be doing is making sure that we can have a copy of it for our own uses that we can modify and run. So in order to do that, we'll click on this little menu button here in the top right corner. We click on this and then clone workspace. If I click on this, now I can make a copy for myself and it will show up in my personal workspaces. So I'll just give it a name. We can put date and my initials so I know what's going on. And if you have a billing project associated with your account, you can select that as well. I'll choose this one here and then clone the workspace. So it'll take a few seconds, and then I will have a version of this workspace that then I can do whatever I want to with, and we can confirm that this is actually my version of this, because at the top it's got my new title, and here it says that I am an owner. So everything's working well. So this workspace is described here. The pipeline that we're going to be using is described in this image. And as you can see from the diagram, the workflow is going to be aligning unmapped reads using the DRAGMAP aligner. And then it's going to be calling variants using haplotype caller that's being run in Dragon mode. So in addition to this, the workspace provides two example workflows that you can use. The first one is this, they're described here. The WGS functional equivalence mode is going to be producing outputs that are functionally equivalent to the Dragon hardware. This is, as Michael was saying. And then the second mode that's available is this WGS maximum quality mode. The maximum quality mode is going to be producing outputs with the maximum quality possible, but at the expense of it not being as functionally equivalent with the Dragon hardware itself. And it's doing this because it's running a few additional steps, like unmapping contaminant reads and then using spanning event genotyping, which can have some effects on functional equivalence. But if what you're after is the maximum quality for your outputs that is possible, then this is what you can use. What I'll be doing today is running through this functional equivalence pipeline though. So, but before that, why don't we take a tour of the workspace? You'll see at the top, we've got these different pages that we can access. Right now we're in the main dashboard. It has all information about the workspace and how to use it and what it does. But if we go here to the data, we can see that we've already have this workspace pre-configured with a bunch of inputs that you can use. So you can run this right out of the box, or you can change this and input your own files. So here we have some sample data. We've got read groups, which this read group data table has these example inputs as that are stored here as unmapped BAMs for multiple read groups. And over here, we've got our read group set. And here we have this file is going to organize our read groups into a single set belonging to this sample NA12878. And down here, we've got all of our reference data. So you'll see here that we have all of our reference data saved as FASTA data, index files, interval lists, and whatever else it is that we want to point our pipeline towards. And then finally, we have here our workspace data, which is just the data that the workspace has access to. So here in workflows, if we go to this page, we'll see that this is where we can actually run both of our workflows. So the first one I said was functional equivalence. This is what we're going to be running. The maximum quality is the second version of that. That runs a few extra steps, but running them is essentially identical. If we click here on the functional equivalence workflow, then we'll let it load, and we'll be taken to this workflow setup page. Here we get information about the workflow, about, for example, which version we want to run. And here we actually have the source of the workflow itself. If I click on this source, actually, it will take me to a new page, which is the doc store. And this is where the actual files are located that the workflow is referencing. And actually, while we're here, I can say that if you want to remove this, if you don't want to run the workflow from Terra, you can use the doc store here to launch it in a different tool like Anvil or DNA Nexus, for example. You can access the source code for this workflow here as well, or you can actually just observe the source code by coming here to the file section, and you can see exactly what's being run. This is being written in the workflow description language, or WDL. If you're familiar enough with that, then you can make your own version of this. You can make changes to it and then run it on Terra or wherever else. So returning once again to the workflow setup page, you'll see here that we have some sub tabs down here that we can click on and get information about this workflow before we actually run it. The first one here is script, which is what we saw on the doc store, but this is what the workflow is going to be referencing when it's actually running. And down here, we've got our inputs. And so the inputs here, you can see that we're already configured here to pull samples and reference information from different data tables. But of course, you can modify this to pull whatever input it is that you're interested in looking at. Here in the Outputs tab, we've got the workflow configured to write data back into a Terra data table. So that's what is going on right here. Once we actually do upload our data here and select the data here with this button and press Run Analysis, we'll be taken to the job history page. In the job history page, you'll see there's nothing here right now, but this is going to be the place where we can monitor the progress of our job. And then if it completes, it'll give us a little green check mark, and we can actually go back and evaluate our files to see what we've got. So let's return here to the workflow, and I'll just run it so we can actually see how it works. All right, so Very easy. We're just going to be following these steps, step 1 and step 2. First, we're going to choose our root entity type. In this case, it's going to be the read group set that I described before. Click here, and then when we select the data, we can see that this is what we were looking at, that NA1287.8 file that is going to be a conglomeration of all of those read groups that we had. So I'll just select that and then press OK. And then run. That's all it takes, aside from the pressing of the launch button. Now, that's all it takes. And there we go. You'll see we were automatically taken to this job history page, which now has information about our submission. And you'll see that we are currently queued. So it'll take a few minutes. When I tested this in the past, it only takes about 3 to 5 minutes to run our example data. It might take a little bit longer, a little bit less time, depending on what data you're running. But for now, what we can do is return to the dashboard. I'll click here and just mention that all the information about this workflow and how you can use it is described here in the dashboard section. And if we come down to the workflow overview section here, you'll see that we have some information, some links that you can reference. For example, this WGS overview link, well, if you click on it, it will take you to the warp documentation for this pipeline. And it's everything that this pipeline does, this workflow does, is described in detail here. There's also a list of all of the inputs and what they are and the options that you can use if you want to customize this for your own needs. And of course, speaking of customizing things, we also have a section for that. If you scroll down a little bit more, we have a section here on customizing the workflow for your own data. And this outlines where to add in custom inputs or where to download input JSON files from the workflow configuration page, things like that. Essentially how you can change this to do what you want to do. So if we return to our job history page, you'll see that now we're no longer queued, but we are submitted. So like I said, it might take a little bit of time, but eventually we'll either get this red exclamation point, which means that the run failed, or using the defaults, as I've tested it, the green check mark will show up, showing that it's actually run successfully. What I did is run a version of this yesterday that it did complete. And so if we look at the data there, well, if we click on the regroup set, we'll see that we can actually get information from this, which means that it was running into here and we can download this file. This is compared to the version that we just ran right now that is not completed, where if we try to do the same thing, there's actually not, this is an empty file. There's nothing in there. So if you want to retrieve your data, you can do that in the data section and you'll have access to all of that. So with that concludes our walkthrough section here. If you want to access this this workspace, again, app.terra.bio, go to the featured workspaces and just search up Dragon. You can literally do that right now after this webinar is done and be up and running with DRAGEN-GATK at your leisure. Okay, so with that, we will then proceed to the Q&A session. Fortunately, we have a lot of time for the Q&A, which means we can answer as many of the questions as we can. And yeah, why don't we go ahead and start? Any of our panelists, if you want to chime in, you can. I will pull up some of the questions and see what it is that you've been asking. To start off with, I'll start with one from the online post that we set up recently. This is a question that comes from John Didion. He asks, how was the benchmark for DRAGEN-GTK performed? Specifically, which reference genome was used, and was post-alt processing run on BWA samples prior to variant calling? Who wants to take that?
Yeah, I can take that. So yeah, the data was processed, or the benchmarking was done using the masked version of the HG38 reference. I know that Illumina was planning to publish some documentation about the mask. So the masking is dealing with some, to my understanding, is dealing with some mapping improvements in the alt context and the decoy context of the HG38 reference genome. I know that Illumina was planning to provide some more blog posts, I think, about that masked reference. Heidi, do you know if there's any updates on that?
So there is a blog post that will be coming soon. We'll share this with the Broad team so that then you can kind of distribute that more widely once it's available.
Awesome.
Great. We've got another question here from the forum that I'll bring up before we move on to the live chat, which is, this comes from Quentin Chartreau. How do I do joint calling from GBCFs produced by DRAGEN-GTK? Should I just perform genomic DB import and then genotype GBCF as usual, or is there something else that we should be doing?
I can take that question partially.
Okay.
So right now we have not fully tested joint genotyping between DRAGEN-GTK and DRAGEN. We know that some of the annotations do not match yet. So the annotations are not guaranteed to be 100% compatible or functionally equivalent with each other. The calls, however, are. So if you're just interested in the calls, then you can absolutely combine DRAGEN-GTK and DRAGEN using the configurations that I have showed on that slide. As in terms of annotations, we are working on getting those annotations aligned in the future.
Okay.
Yes.
And can we do joint genotyping from the GBCFs that we get from this pipeline?
James, do you perhaps know if that should be working as of now?
Joint genotyping for DRAGEN-GTK results?
Yeah, so if the GBCFs produced by the pipeline directly, can they be used by DRAGEN to do joint genotyping? Or is there anything additionally that we should do to process those?
So I think between, if we can joint genotype between DRAGEN-GTK and DRAGEN.
That has certainly not been something that we have tested. We know that there are some annotation differences, but those largely are not super important. I would say that is a use at your own risk approach. Though given that they're functionally equivalent and the results are very similar, it probably would work barring some issues with annotations.
Okay, fair enough. And along those same lines, do we have any idea of how much processor power these pipelines need? Like if we're actually going to be running, DRAGEN-GTK or DRAGEN pipelines on a 30x human genome, is that what's the price going to be like ultimately? Is it going to be more economical to use DRAGEN-GTK versus DRAGEN, or the other way around? Do we have any idea of benchmarking that we've done with that?
Yeah,
Michael has some.
I got some numbers on running. I am not aware. I don't 100% know the cost of running DRAGEN for full genome. I think the user cited in the question cost of around $9 or $9.50. Maybe you know better, Heidi. I know that for 30x genome on the DRAGEN-GTK side, running the whole pipeline is between. Okay, let me actually look at the numbers to make sure. Is between $5.50 and $8 per sample. That is being run in the cloud. We usually run the pipelines in the cloud, so that cost corresponds to the cost that charges us. Yeah, sorry.
I can chime in about the DRAGEN hardware accelerated cost. So on our Illumina connected analytics platform, it costs $5 per hour to run DRAGEN, and it's a little bit slower on the cloud than on premise, but it takes about an hour to do that fully featured genome with all the callers. So it's around $5 to $7 to run it on our Illumina Connected Analytics platform.
Okay, thank you for those answers. I'm seeing here in the chat, we have a question here from Kumsa. I think we've already answered it, but maybe we could get some more information. Have there been any efforts or thoughts about creating an open source GPU accelerated version of DRAGMAP?
Take that one. So that's definitely something that it's under consideration, as we look at, how we can make our tools more accessible and usable. It's something that we're looking at, and that's probably all I can say, but yeah, something definitely under consideration.
Great. And also we have one from Shuyan asking, has there been any validation done on WES data?
I think so we have not been running functional equivalence evaluations for exome. We have only looked at whole genome at this point. However, we expect the results to be very similar, obviously. But at this point, we cannot guarantee that you will be able to combine exome data one with DRAGON and exome data one with DRAGEN-GATK without any batch effects, even if using the functional equivalent configurations.
Okay, so it's another one of those use at your own risk type things.
Yeah. It could be that it could well be that they are functional equivalent, but we cannot, at this point, guarantee that.
Okay. Are there any special considerations if somebody wants to do this? Are there any special considerations that they should take into account when trying to do this? What should they be thinking about in order to avoid any negative repercussions?
So I think it should be pretty straightforward running DRAGEN-GATK on exome. I know that the warp pipeline. For those of you who don't know, the warp pipeline is a collection of open source WDL pipelines to run all sorts of genomic analyses. And there are also pipelines for running whole exome data. If run with this swap pipeline for exome, then I do not expect any complications for running the pipeline. If they are functional equivalent, we don't know. So
okay,
use at your own risk.
Okay. All right, we've got a question here from Anonymous asking, does DRAGEN-GATK work for low coverage data? Looking at 1x to 5x coverage. What are our thoughts on that?
I can take this. So DRAGEN-GATK, there shouldn't be any special getting to the previous run of questions about this. This hasn't been directly in our testing framework, looking at very, very low coverage data like that. But DRAGEN-GATK, it's about the same as it would be for running regular GATK for low coverage data. There's nothing that is uniquely worse or better about the algorithms that have been added for DRAGON that should affect that. If anything, it might result in better overall scientific results, which is obviously what we expected and why we went through with this process. But that is something that you will have to evaluate for yourself.
Okay, thank you. Along those same lines, we have a question asking, they're saying that DRAGON provides a forced genotyping setting to ensure that a user-provided set of SNPs are always included in the VCF output. And the question is that possible with DRAGEN-GATK? Is there something like that?
Yes, there's a feature in GATK, both regular haplotype caller and DRAGEN-GATK, called genotype given alleles. It lets you input a VCF file, and it will force that VCF file to be genotyped at all of the sites where it's relevant. So that is a feature, and that should work just fine.
Okay, and that is described in the technical documentation for DRAGEN-GTK, correct?
It's certainly in our technical documentation for GATK haplotype caller.
Yes. Okay, so if they want to find more information about that, they can look that up in the haplotype caller documentation. Also, a question, are there plans to expand DRAGEN-GTK to large variants?
So my question for this user, which I guess I can't ask because this was asked online, is what they mean by large variants in this case. Do they mean structural events? In which case DRAGEN-GATK, like there are tools that work on structural events, and there might be news in the future about collaborations between, stemming from this about that, but we don't have anything to say on that now. There are other tools that are better suited to structural variants than GATK. In terms of DRAGEN-GATK on slightly longer events, like insertions, deletions in the range of 100 plus bases, there are options in GATK and in DRAGEN-GATK that might improve performance there. But those events are fairly rare, and we haven't spent a lot of time evaluating how well we perform on them. But that is sort of like tinkering that would have to happen on the side for your own application.
Mm-hmm. And this question was from the forum, but I actually think that they might be here in the chat. So Mark Gonzalez, Porta, if you're here, if you want to give some more details about your question, we can reevaluate that. Okay, we've got a question here from Kunsa. It was in the chat, and I think we already gave them some answers, but I think they were trying to shame us for our bare bones documentation for DRAGMAP. So what are our thoughts on that? Are we going to be expanding the DRAGMAP documentation, and what are our plans with that?
Yeah, it's good feedback. We sort of recognize when we put this out there that this initial version had kind of sparse documentation. So the development team at Illumina will be iterating on that, and I'll definitely take this feedback to the dev team. We noted that it's bare bones.
Okay, great. We have been shamed, so I think that we should be expecting some more developments in that soon. So keep your eyes open, everybody. Okay, and let's see.
Maybe just to follow up clarification
please, Michael.
Some of the questions. So DRAGEN-GTK is not a whole separate new tool. It's a collection, it's a configuration of existing tools. Maybe just to clarify that with the documentation about haplotype caller that came up. So if we run variant calling in DRAGEN-GTK mode, that is basically just another argument that is passed to the haplotype caller task. So everything else, the infrastructure of GTK remains the same. And this additional argument to the haplotype caller step just enables a few certain features that make it compatible and improve variant calling, actually. And also make it compatible with hardware DRAGEN. Okay.
Diana asks us a question here. What are our plans for expanding DRAGEN-GTK to somatic variants? We have plans for that in the future?
So the Illumina and Broad are kind of laying out our roadmap for future innovations that we're going to be doing together, and that's one of the things on the table. But I don't think we can announce yet what we're planning on tackling together next.
Okay, and yeah. So any.
We have one other open question in the Q&A, Derek.
Please, Genevieve, why don't you tell me which one that is?
Yes, from Mayank Tandon. Are the functional equivalent results available to view outside of Terra? Are they for somatic or germline variants or both?
That sounds like a question for me. They are so in the blog post that has been published on the DRAGEN-GATK release, there is an article linked on functional equivalence, which goes into technical detail about also the plots that I mentioned, that F1 plot, and how exactly all that works. And on the bottom of that article, you find all the plots between DRAGEN-GATK and Dragon in terms of functional equivalence, as well as plots for how that equivalence looks if we decide to not turn off those features that I mentioned, which would give us not functional equivalence results. So we would not be within the noise of just genomic data analysis, but we would still be very, very close and very compatible with each other. So if users decide to turn on these features and improve variant calling even more, then they can certainly do that. And plots showing how equivalent we are there, despite not being completely functional equivalent, are also in that article that I mentioned. And they are run on only germline, not somatic data.
Thank you, Michael. And I think we may have already addressed all the questions, at least the ones that I can see in the chat and on the forum, which is great, fantastic. But that means if anybody has any other questions, please post them. In the meantime, maybe I can ask if we're allowed to say what our plans are for version 2.0 of DRAGEN-GATK, or not, maybe not 2.0, 1.1. Is there anything that we can let people know about, or is it too early for us to have any idea about what features we're planning on adding in the future?
I think if I can jump in, I think it's probably a little early for that. We've just had a big release, and I think we'd love to get people's feedback on, if they try it, how does it work for them? What are the kind of the requests of things that we could improve and so on. So I think right now we'd love to see how this lands, how it works for people. And obviously there's a ton of improvements that can be made in various directions. And we'd love to get feedback from the community to help us kind of figure out what would be the most impactful thing that we can do to serve their needs. Yeah.
Yeah. And if they do have feedback, where should they direct that?
On the open source DRAGEN-GATK, certainly the GATK forum, and Genevieve is the curator of the forum and can tell us more if there's very specific guidance. But generally speaking, the GATK forum is a great place to tell us everything from how happy you are with the tools to how frustrated in some cases. Whatever we can do to help you use the tools effectively, that's the place to tell us.
Fantastic. And we do read everybody's comments and posts on the forum. So if you do have any input or questions, please go there and let us know. We've got a new question here. Any comment on panel-seq in regards to downstream processing for DRAGEN-GATK? What are we thinking? Panel-seq.
Can the question poster clarify? Is it
Yeah,
somebody who's posting in the chat, or because I'm not sure entirely what they're referencing, if it's panel sequencing or not. Okay. But it sounds like a use case that's not something we have, unless somebody jumps in and tells me otherwise. I don't think it's something that we have focused on so far. We've really, this has been a really ambitious project of marrying two different tool sets and trying to find, as you were saying, the synergy of peanut butter and chocolate. So we focused on that very specific use case because we want to do that really well before we start moving on to branching out to other use cases.
Fair enough. And we've got about 5 minutes left in the hour, so maybe we could, if anybody has anything they want to add, maybe that wasn't covered in the talks or the Q&A that they want our audience to know about, now's the time to share. What do we think? Does anybody have anything they think is important to bring up at this point?
I would just add, there was a question about structural variation, large variance, assuming that was structural variation. Both DRAGEN and GATK have tools and pipelines to address these. James made a comment about GATK not being necessarily the best suited. What's interesting on that side is our methods team has been working on with collaborators, research teams, to develop a pipeline that actually takes multiple tools that are popular in this domain, and kind of trying to make a best of all worlds pipeline that leverages the various strengths of the various tools into a coherent pipeline. And that's something that I believe the team is preparing to make. It's already public and available, but I believe our team is doing some work to make those more accessible. More documentation we hear is always appreciated, things like that. And so hopefully in the new year, we might have some materials to provide to the community on this topic. And I see that Genevieve just posted a link for those who want to check it out on GitHub.
Yes.
Thanks
Genevieve. And so we're very fortunate here to have Heidi and Deepthi here from Illumina. I'm wondering, do either of you have anything that you want to say before we end?
Yeah, just that we're super excited for these methods to now be available to the community. We do want to echo what Geraldine said, that we really want to hear feedback about what's useful, any pain points in using this. We heard the documentation point loud and clear, but we love feedback of most impactful areas to invest for the future. And for any users who are using both DRAGEN and then are trying out DRAGEN GATK, we'd love to hear from you as well of kind of how that experience is. So yeah,
echo Heidi's comments, really, and thankful for this opportunity to present in front of this audience, and really excited to hear your feedback.
Fantastic. Okay, well, thank you everybody, all of our panelists. Thank you everybody who's attended. Your questions are invaluable, and we always look for feedback and what your experience is like using the tools that we're creating, so that you actually have, so we have a baseline, like we can get back to reality and not just create tools that nobody's using, just like in the ether. So I just want to say at the end of the hour here that if you do have any comments or feedback, go to the gatk.broadinstitute.org forum. It's linked there on the main page. We have that webinar discussion section. It's labeled as being for this webinar. If you go there, you can post any additional questions that you think of after the fact. You're going to have that staircase wit in 5 minutes after we close out. But if you have any questions, go ahead and post your questions there. And we are looking there, and we're going to be trying to answer all of the questions that we can. So thank you very much, everybody. And with that, I think that's it for us. Thanks, everybody, and have a good rest of your day.